Good evening, Mr. Ray. Good evening. How are you guys doing this evening?
Good, thanks. Hey, Mr. Ray.
Good evening, Jacob and Latavia.
Yes, sir.
How are you guys doing?
I'm good, thank you.
Good.
That's good. That's good. And Latavia, were you able to get that test? Yeah, you got it situated.
Yes,
Yeah.
I have.
All right, perfect. And she did send me some more names. I have to check just to see who they are.
Hello, Mr. Ray. It's William.
Good day, William. How are you doing today?
Good, and yourself?
I'm doing well. Thank you very much. I'm doing great. Just trying to open up something real fast. So if I seem distracted, that's why. All right. I think it's unit 3, yeah. All right, unit 3 is up and running. Okay, so I'm gonna start going over the names, just making sure I get everyone on here.
Hello, Mr. Ray.
And good day, Gennaro. Was that you?
Yes, it's me, sir.
All right.
I just got in here.
Say that again?
Mr. Ray.
I just got in. I was too busy tuning into the Dodger game.
Oh, right. All right. And somebody else just said good morning to me. I mean, good evening.
Hi, Good afternoon, Mr. Ray.
Good day. How you doing?
Good. Just here.
All right. Yes, welcome, Dina. I'm just going to go through your names again because I'm writing them down. So just George, welcome.
Yeah, Mr. Ray, greeting to everyone.
Hey.
Yeah.
All right, and Gennaro again, just writing your name down, and Jacob, just writing your name down, but welcome again.
Thank you, sir.
You're welcome. And Norma, welcome.
Hi, Mr. Ray.
Good day. How are you doing?
I'm doing good.
That's
Thank
good.
you.
You're welcome. And Susanna, welcome to you.
Hi,
How are you doing?
I'm good. How are you?
I'm doing well. Thank you very much. And Daniel, welcome. Daniel B.
Hi, Mr. Ray. How you doing?
Fine. Thank you. Welcome. And just to let you guys know, Daniel C, he passed all his tests, so he has his certification.
Oh, wow.
Congratulations.
All right, right on.
Yeah, so if you know him or if you have his contact, you can wish him congrats. I'm gonna send him some congrats, and I'll just say
That's so nice.
class as well.
For who?
Daniel C.
Oh, he did it too?
Yeah, he passed all his tests, so he's got his certification.
Oh, wow.
That's awesome.
And he was trying to get them all done in 3 months, and I must take my hat off. He was able to do that. So yeah.
That is awesome. That's right.
The palace is gonna do.
Did somebody say something? Okay. All right, Latavia, welcome again. Just writing your name down.
Sure. Thank you.
And William, again, just writing your name. All right, Clemente, welcome.
Doing, Mr. Ray.
Good evening
Mr.
to
Ray,
you.
I have to let you know ahead of time, next Thursday, I will be having a heart surgery.
Oh, wow.
Yeah,
Okay.
but I will be like in other words, next Thursday, I won't come in on that day, but on Tuesday I will be back.
Okay. All right. And I'll be looking forward to seeing you.
Okay.
And I know they don't technically want me to say this, but you're in my prayers.
Thank you. Thank you.
Yeah, but yeah, definitely that's something serious. So, you know, I'm just going to say it. All right. But yeah. Okay. And let me know how it goes too. You know, once you're able to communicate, you can just say, Mr. Ray, I'm ready. I'll be seeing you soon, etc.
Okay. Really appreciate that. Thank you.
All right. Thank you. You're welcome. All right. And good evening, Raymond. All right. Good to see you. Dina, again, I'm just writing your names down. And Dorcas, good evening.
Good evening, Mr. Ray.
How are you doing today?
Good, and you?
I'm doing well, thank you very much.
You're
And
welcome.
Salvador, welcome. All right,
Hello.
baby. Okay, yeah, you can hear me. All right, so it's good to have you guys all. We're gonna be missing a few people, had a few apologies come in, a few people couldn't make it this evening, so we're gonna go ahead and start. But before we do that, any questions regarding any assignment, anything that we've covered?
Mr. Ray, before I have my question, on Thursday, I might be running late because my son, I have to be in Fort High. I guess they're doing like a drive-through. He wants to receive like a gold medal.
Oh, okay.
So I just take an excuse, but I'll be in class. I might be late.
Okay, thank you for updating me on that, and congrats to your son.
It's on Thursday. Thank
Was that,
you.
you said a gold medal, so was that a track and field event?
I have no idea. They just said I think it's on academics. I don't know.
Oh, okay,
But they want to give them
gold
some-
medals.
Yeah,
All
so
right,
I-
that's just as good, an academic medal. That's really good. All right. Okay, so any questions on the assignments, or any of the homework assignments?
Yeah,
Yeah,
Mr. Ray.
Yes.
Number 7, for when you use the workbook, you see, when we have this letter X, I always have problems.
Which page is that again? Just for
Page 71.
71 in
Yes,
the
on
workbook.
workbook. Yeah.
Yeah, I had assigned you guys some problems there.
Yeah. I
Yeah, you
myself, I for one, when it comes to
Number 7, you didn't have to do number 7.
okay.
Yeah, I had assigned number 4 through 6, and then we skipped to number 21, I believe it was.
21 and 26, Mr. Ray.
Yeah, 21 and 26. The others, you guys we're gonna learn that today.
Okay.
Yeah, so out of those numbers, yeah, so number 7, you would have trouble because we haven't got to that yet.
Okay.
Mr. Ray, so on the, can you hear me?
Yeah, I hear you.
Okay, so on the we did on the student book, we did 7 on 50 page. We did 6 on page 57.
Right.
You help us at 6, and then you left us for homework.
Number 58. I mean, number 8. Yes.
Number 8. Yeah, and I couldn't understand it, and I even went to the answer key, and I saw it, and it took me like an hour to figure it out why they give us the answer it was, but it was pretty hard to get to it.
So did you understand it like by time?
I do now, yeah, but it took a while. Even looking at the answer, I couldn't get it.
All right. Well, do you wanna grace us with the answer? That will help you.
Not really, but yeah. So.
Well, I'm glad you tackled it that way, because some people would give up, but the fact that you went through, that shows good integrity and tenacity there. So I'm glad you went through that.
So yeah, Mr. I'll let you do it, but I did understood at the end, that I had to multiply the 2, 3 times, and then move the 6 over. It did the same thing over with the next one, and then to add them up, I had to have the same denominator. Yes.
Yeah.
Yes. So I eventually got it, but it was pretty challenging that
this one does require a bit of work if you have to do it without a calculator. Now, with the calculator, you can just type it in as you see it. And if you type it in as you see it, it will give you the answer. But we're going to do that second.
Okay.
Because this could be a question where you have to do it without a calculator. A lot of times questions like these are without calculators. And the way they do it is that they disable the calculator on the computer, and the test invigilator won't allow you to use the calculator in your hand. So you would be forced to have to do it by hand. So if that happens, let me rewrite this because it did not come out clear. So first we have let me see, do I have enough space? I'm gonna write it up top first. 6 times 2 to the power of -3 plus 5. I'm not gonna put those parentheses for the 5. 5 times 2 to the power of -4 plus 4 times 2 to the power of -5. All right, so anyone else, did you have any problems with it before I go on? Did anyone else understand it? You were able to get it done?
No, not me.
All right. Okay, so these ones can be pretty difficult, when you first get exposed to them. The key is practice, of course. The more practice you get doing them, the easier it will get. So let's go ahead and try these, and I'll try to make up a few to practice some more. So you have to remember the laws of exponents. Remember the laws of exponents, if the bases are the same and all those different things. So this one here is dealing with negative exponents. So that means you have to remember the rule for negative exponents. And does anyone remember what the rule is for negative exponents? What do we do there?
Oh, it should be 1/2. Let's say 6. It's
Right.
1 over, yeah.
We put 1 over whatever that negative power is, and we change it to positive. So for that first one, if we do the first one, 2 to the power of -3 can be rewritten as what?
Yes, it will be 1 over 2.
1 over 2
power of 3.
right?
Yeah.
Then the next one would be 5 times
1 over 2 in the power of 4.
right? 1 over 2 to the power of 4, and then the last one, 4
Would be
times
4
1 over
2 in the power of 5.
power of 5. So remember, they're asking you to find an actual value this time. So that means you're going to work it right out. Now notice everything's in fraction form, and then we have an integer. So that means that you have to actually simplify it to get to your answer. So for the first one, in the denominator, you have 2 to the power of 3. And 2 to the power of 3 is equal to what?
8.
8. So that becomes 6 times 1 over 8. Plus 5 times, what's 2 to the power of 4? What does that give?
16.
16. Notice that it's just another 2 being multiplied. And then the last one is going to be 1 over 2 to the power of 5 is?
5. 25?
Close. 2 to the power of 5.
Oh, I'm sorry.
So remember, 2 to the power of 5 just means you're multiplying by 2 5 times. So sometimes you could use the one that's right next to it. 2 to the power of 4 is 16. If you multiply 2 to the power of 4 by another 2, that's what gives you 2 to the power of 5. But since the answer is 16, just multiply 16 by 2.
32.
It'll be 32. Okay, so now we can simplify that some more. Remember, when you multiply fractions and numbers, it's the same as multiplying the number over 1. And when you multiply fractions, you multiply straight across. So technically, you just need to multiply 6 times the numerator, because 1 times 8 is just 8. So that means I will have 6 over 8 plus 5 over 16 plus 4 over 32. All right, let me just write down Marisol's name. All right, so we have, excuse me, we have 6 over 8 plus 5 over 16 plus 4 over 32. Now remember, to add fractions, what has to be the same?
The numerator.
Not the numerator,
The denominator.
Denominator, the bottom number. So I need to make all the denominators the same. Now the thing is, you can see, hopefully, all of these are, in a sense, they're multiples of each other, the previous term in the denominator. But sometimes we can make our work shorter by looking at the answers. We would normally choose the larger value, 32. But notice 32 as a denominator is not there. And it's clear it can't be D because you have all positive values there, so you cannot get a negative. So that means it has to be one of these 3. And so that means I can choose either 8 to be the denominator or 16 to be the main denominator there. And so what we want to do is think, well, how can I get to 8 or 16? The easiest one would be just to make all the denominators 16. And that way I can see if this one is the answer. If I make them all 8, it's going to be a little bit difficult because I have to divide 32 by 4 and 16 by 2. And what I do to the bottom, I have to do to the top. So I'm just going to go ahead and make all the denominators like 16. Now, it could happen that it ends up being 8 or 2, but let's just go ahead and see. If I wanted to make the last fraction 16, I would have to divide by 2. And what I do to the bottom,
Do to the top.
do to the top. So I divide the 4 by 2 as well. So I divide both. And the reason why, again, I'm doing that is to make all the denominators 16. That means I don't have to do anything to the second number, but the first number, I would have to times it by 2 to get 16. And what I do to the bottom, do to the top. All right, so once we do that, 6 times 2 is 12, and that's 12 over 16, plus 5 over 16, plus, and I'm dividing that last fraction, not multiplying. So 32 divided by 2 on the bottom is 16, and 4 divided by 2 is 2. That means I only have to add the numerators together. And 12 plus 5 is 17, and 17 plus 2 is 19, and therefore that's my answer. C is 19 over 16. Now remember, the reason why I chose 16 was that was just the easier route. I didn't choose 16 because I saw 16 there alone. It's because I noticed that I could use 16, 8, or 2. And so I chose 16 as that was easier, and it just so happens that is the answer, 19 over 16. Any questions with that?
But if we use 32, we still get the same answer?
Yeah.
Yes, it would just reduce down. You're going to end up with 38 over 32, and then you would have to reduce it down to 19 over 16. So it was less work to just start to work with numbers that have already been reduced.
For the second to last step, you chose to multiply by 2, 6 over 8, then 5 over 16 stays the same, but because we're trying to get 16 as a
Denominator.
as the denominator, and then we divided by 2.
Right.
With 4 over 32.
Right. So that we could get 2 over 6. Yeah.
Okay.
Remember, with fractions, we have equivalent fractions, so I could change it. Remember the pizza slices. If I cut a pizza into 16 slices and I ate 2 of those slices, it would be equal to somebody eating 4 slices out of 32 slices cut of the same size pizza. So it's the same fraction, or is equivalent fraction rather. All right, any other questions with that?
Yeah. My question is on the third step where you have 6 times 1. So we don't have to multiply the number outside with the one in the denominator?
Well, this one comes from our understanding that when you multiply a whole number by a fraction, what was that, 1/8? Remember, to multiply a whole number by a fraction, you have to turn the whole number into a fraction. And the way you do that is just to put any whole number over 1 makes it a fraction. When you multiply fractions, you multiply straight across. 6 times 1, which is 6, and 1 times 8, which is 8. So if you do that enough, you start to realize, you know what, whenever I multiply a whole number in a fraction, just multiply the whole number and the numerator.
Okay.
Does that help?
Yeah.
Sure, didn't sound confident.
Mr. Ray, I have a problem. I tried to solve it when we look at workbook page 71.
Say that again?
I have a problem.
With 71?
Yes, using the workbook.
Okay.
Yeah, that is number 8. You know that where we have the planet and masses.
Don't worry about number 8 yet. We haven't got to scientific notation yet.
Let me just give my own idea. It's just when I use a calculator.
I have a question.
Calculator, yes.
Well, we're gonna get to that real soon. Like that's what we're doing next. Like we're gonna get to scientific notation.
Okay.
I just don't want to introduce something that I haven't introduced yet, because it could cause confusion before we get there.
Okay.
Yeah.
I have a question.
Keep number 8 there. Once we get to scientific notation, just make sure you remind me to look at number 8. But don't do it until we get there. That way no one's like, what is this, before we even get there. All right. I heard somebody say they had a question.
Yeah, I do. Mr. Ray, I see where you got the 1/8 and the 1/16, but the 1/32, that's where I was like, I'm confused.
Because we have 1/2 to the power 5, and 2 to the power 5 is equal to 32. So right here, we got that because it's a negative power, so it becomes 1/2 to the power 5.
Okay.
2 to the power 5 is 32, so 1/32.
Oh, okay.
All right. Any other questions regarding this topic or any older topic? All right. If not, do we need to calculator. So let me show you how to do this in the calculator. Because your calculator is basically a what you see is what you get, you literally just type it in as you see it.
All right.
So you can try it in advance. I just need to find the calculator real fast. But if you remember the steps of how to use the calculator, you know, we went over how to write exponents. So if you just type it in literally how you see it, you can type it in and the calculator is just going to bring you the answer. All right, so here you guys see the calculator, correct?
Yeah.
Yes.
Yep.
All right. So to do it in the calculator, you just type it as you see. Just do 6. You could put times or you could use the parentheses. Times would be faster, but if you really need to type it like you see, then just do open parentheses 2, raise it to the power of, what's that, -3. Make sure you come out, because if you don't, you're going to be writing all up top there. You're going to get an error. So make sure that you click the arrow to come back down into regular number land. All right, close the parentheses, plus, open, you could type it literally exactly how you see it. If you're not sure of the syntax, right, raise it to the power of, is that -4? -4. Make sure you click the arrow to come out, parentheses, plus, open parentheses 4, close the parentheses, open them up again, and 2 to the power of -5. So 2 to the power -5, use your arrow to come out, close the parentheses, and then hit enter. And there you have it. It'll give you your answer. Okay, any questions about using the calculator?
Yes.
Can you repeat that one more time? Do it over.
Sure. Just remember, type it in exactly how you see it. So you see it says 6 times 2 to the power -3. The beauty of this calculator when it's in math print, it won't do this in classic mode. You have to make sure you're set in math print. So if you've forgotten that, click mode, make sure math print is highlighted. The second click to come out. All right, so then to start it, we have 6. You could hit times, but if you're, you really want to stick to what you see in the book, then do 6, open parentheses, exactly how you see it in the book. 2, remember to raise the power, it's the little caret symbol. Remember when you click on negative, do not hit the subtraction sign, hit the negative.
For
Yes.
the negative sign, where do we click at?
The negative sign right there at the bottom.
Okay, at the bottom. Okay, thank you.
Where it said, right next to enter on the left side.
Yeah.
Okay, so once you do that, you click plus.
They close parentheses. I close it, but they give a few, I don't know.
Did you close the parentheses after you push the arrow to come out? Because if not, you're up top here.
Which arrow? Which arrow? That's
You see this arrow that's blinking?
Yeah.
Many students forget to click that to come back down. So your cursor should not be up top there. If it's up there, you're going to get arrows.
Right.
Okay.
Right? Treat the calculator like it's just like it is, right? Your font is right now on the top.
Keep right arrow.
That's, you don't write numbers up there. So that means you have to tell the calculator, come back down, and you use the navigation tool to do that. All right, so close the parentheses. Remember, this calculator is a what you see is what you get. What you type is what you get out. What you see in the book, you can duplicate on the calculator. That's why people like these calculators.
Then
Very
plus
powerful. All right, so plus, open the
5.
parentheses, 5, close the parentheses. Timesing by just open the parentheses again, just type what you see. 2, raise it to the power, hit the negative button next to the enter button. -4, don't forget, look at your calculator. Some people just type and they don't look up. The calculator is trying to help you by blinking with the cursor and an arrow telling you push the right button. So you push that right button, close the parentheses. And then plus open parentheses, 4. You don't really need the open parentheses there, but anyway, 4, close it, open it again, just type in what I see, 2 to the power of -5. Don't forget to click the arrow. Come back down, close the parentheses, then hit enter. And you get the correct answer, 19/16. But remember, there are parts of the test that you have to do by hand, and the majority of the test is calculated. So if this question came up on your test, you could just use the calculator.
Okay.
I hope so.
If you know how to use the calculator, you can definitely boost your score. For those who don't know how to use the calculator, sadly, they might try this and get errors, and then they get stressed out, and then they end up getting it wrong having a calculator. You don't want that. You want to make sure that you purchase this calculator and that you learned how to use it, and that it makes you even more comfortable on the test and thus boosting your score.
Mr. Ray, a question. I know I'm trying to jump the gun, but at the test site, are we going to be able to use some scratch paper? Can we do that too, or no?
Yeah, well, it's not scratch paper anymore. What they do is they give you a whiteboard with a dry eraser, dry erase marker. And
sometimes that helps.
Yeah, they give you the ability to write on the side.
Okay.
I'm not sure what Fontana's rules are. Some places they'll give you 2 or 3 of them. Normally you can write on the back and the front, and then once you run out, you just erase it once you're finished. And then you just start a new problem. So they might give you extra. Some testing sites, you can keep asking for them because you might want to keep your working so that you could check your answer later. So it just depends. I don't know if anyone has taken it at Fontana yet and can verify what they do. But yes, they do provide you with a scratch source so that you can do your working. Okay, that's where we're stopping for this part, unless anyone else has questions regarding the homeworks from the workbook number 4, 5, 6, or 26. They were pretty straightforward. It's like one of the first times the questions on the student book were easier than the workbook. All right, so if there are no others, I said I was going to give you a few more to try. So let's just try these and see how you guys do. I don't have a clue what's going to come out of these. So let's say we had, once I get my pen set up, let's say we had 5 times 3 to the power of -2 plus, let's throw in a fraction, see how you guys do. 3/2 times 3 to the power of -4. That's going to be kind of big. Let me turn it down just a bit. Put there 3. Yeah, let's put a 3 there. And then the last one, let's just say a minus sign there. Subtract, say, I already have a 3. 4 times 3 to the power of -4. All right, so try that out. Don't use the calculator yet. Try it by hand first. Once you get your answer, then try to do it on the calculator. You do want to practice doing it by hand, just in case That's the one that pops up on the test. And you notice from the first one, it combines a lot of different stuff, fractions, exponents, multiplication, and addition, all into one problem.
Again.
So once you get your answer, try it in the calculator. So if you sent me an answer, try it now in the calculator, see if you get the same answer.
Mr. Ray, this is Clemente.
Yes.
I'm having a hard time trying to figure it out on the calculator. How would I punch that in?
Well, did you understand how to type it in when we did it on the practice run on number 8?
No, I didn't, honestly.
Okay, well, I don't want to go over it yet because I do want you guys to try it.
Okay.
So basically, you're just gonna type exactly what you see. Like,
I see. Okay.
yeah. So as long as you know where the functions are on the calculator, just
Yeah.
try to type it just like that. I'm gonna do it again, but I
Okay.
do want everyone to be able to try
Okay.
it first.
All right. Thank you.
All right, you're welcome.
Mr. Ray, I was stuck in my step 3, but I tried finishing it on the calculator.
Okay. And William, I see you sent me an answer. Did you do that by hand and calculator, or just calculator, or just hand?
I did calculator, but I kind of gave up on the third step or fourth step.
Okay.
So I
and-
used my calculator.
all right. And how about
Yeah.
you, William?
Both.
Both. Okay. Well done. So your answer is
Miss-
correct. So well done,
Mi-
William.
Mr. Ray, this is Salvador.
Yes.
So I did the same thing as she said. I got my first step, and convert all of them, and then when on my third one, I guess I gave up too soon because after I did it on my calculator, I realized unless I did it wrong on my calculator that the numerator it's pretty big. So I guess I should have just kept on multiplying.
Yeah.
that-
Sometimes we might think it's too large or too small, and so we stop. But that's why you just want to be able to do whatever is required. Because reality is you could get a large number.
Okay, and so when I look at my calculator, I realized that I could multiply and then get my answer now over here. But I guess that'll be cheating because I already did it on the calculator, huh?
Well, somewhat. Now you want to see, can you work to the answer? Sometimes we know what the answers are and we can't show how to get there.
Okay, so I think I got it. I got it. So,
all right, so try it out. See if you can work to that answer. Send me the answer. I just want to see if it's correct.
okay.
I'm trying to send it, but I don't know. I can't find the private chat.
Just click on that little arrow where you see everyone.
Everyone?
If you're in the chat area, you should see right above where you can type. It says like 2, and then like you can have everyone, etc. All right, Gennaro, that's correct.
I'm a little familiar with the calculator. It's I also have it here on by hand, and I'm looking at the previous problem.
Right.
I'm right at the part where I'm supposed to divide. You know how in the last problem we divided we're trying to get the same denominator.
Right.
That's where I'm stuck at right now. I'm
Okay,
looking at
so
it.
you could do it the long way in terms of writing out what the multiples are.
Mm-hmm.
And since you kind of know what the answer is, you can kind of manipulate your way there.
Okay, because sometimes I try to figure out a method I could. Cause I know I'm looking at time. Time has always been a factor for me in these tests.
Right.
And
so what you want to do, and I'm glad you brought that up. This is a commercial break. So for everyone, if you get stuck on a question, you can flag it. So hopefully when you practice the GED ready, you'll see what I mean. But you flag the answer and come back to it later. So whenever you like, this is going to take some time, flag it, come back to it once you're done.
Yeah.
So you don't get stuck on a problem. But yeah, I know what you mean. Time is a factor, and so practice is how you get through it. You got to practice it over and over and see if you can get faster. Even if it's the same problem that you've already done before, it can assist in helping you to work quicker and more efficiently.
Yeah, time was the big factor for me in these last three.
Right. Yeah. So yeah, time. I had said that before. Time is a big factor. But once we go over algebra, that should help as well, because the test is mostly algebra, and all of this stuff builds up into algebra. If you can master Unit 1 and these 2 lessons here, then you can pretty much get through algebra.
Okay. Awesome.
All right. All right, Dorcas, that's correct as well. All right, I'm looking at the time. It is ticking away from us. So I'm going to start it. You can still work on it as you watch over. I'll work a little bit slowly so you can see that. All right, so starting with the first one, remember these are all negative powers, which means we can manipulate them. And if we don't have the option to use a calculator, we can use our understanding of the laws of exponents. So this is going to be, once I get control of the pen, when we rewrite this, we're going to have 5 times what?
1, 3, 2.
Right? 1 to the third. 1 over 3 squared, right?
3 squared, there you go.
All right, and then for the second one, what would I have?
1 to the 1 3 cubed.
1 over 3 cubed. And then the last one, I'm going to have 4 times
1 to the second, 2 to the 5th power. 1 over 2 to the 5th.
For the last one?
Yeah, isn't it?
To the 4th.
Yeah, 3 to the power of 4.
3 to the, oh, I messed up.
Yeah.
What am I looking at?
I think that was the last one.
Because I was looking at the steps on the previous one. I think I got the numbers mixed up.
Yeah, that was from the last one.
Okay.
All right. Okay, so now we can start simplifying it some more, right? We have 5 times 3 squared is 9, so we can make that 1 over 9 plus. Now, before we do this, we could make it a little bit easier for the second one by canceling. I don't know if you guys remember, but 3 cancels down to 1. Right? If I had 3.
Okay.
Hello? Okay, thought I heard somebody calling me. All right, so if you had 3 over 3 squared, remember that can cancel, and one of those cancels, and so I'm left with 1 over 3. The long way is, I have 3, let me do it this way. The long way, I could have just undid that faster first time. The long way to understand the canceling is that I have 3 over 3 times 3. And so because of that, one of the 3's cancel. And so I'm left with 1 over 3. So basically I could cancel the 3 and take away 1 from that number, and I'm left with 1. So I could do the same thing here. I can cancel the 3 and take away that 3 to leave it with 2. That's one way I could do it. It makes it a little bit easier to work with in terms of the size of the number. So that leaves me with a half, because the 3 canceled. And then 1 over 3 squared would be 1 over 9. Right, so now it just makes it a little bit smaller. So instead of 3 over 2 times 1 over 27, it's a little bit easier to work with. 1/2 times 1/9. And it's still the same value. All right, and then the last thing there, I have subtract 4 times 1 over 3/4. So, not 3/4, sorry. 3 to the power of 4. What's 3 to the power of 4 equal to?
81.
81. All right, and there's a 1 there.
Okay, that's where I, oh, hold on.
All right, so now I can start multiplying through. Remember, with dealing with a whole number, you multiply the numerator and the whole number. So that's going to be 5/9 plus, if I multiply straight across, 1 times 1 is 1. 2 times 9 is
18.
18.
Mr. Ray.
Yeah.
Have a question with that second portion, which is where we at right now. So,
Right.
3 over 2 times 1 over 3 cubed. I did multiplying straight across, just as it is. So I did 3 times 1 is 3. Then I cubed the 3. 3 by
Right.
3, 9 by 3, 27.
Right.
And then I did 27 times 2. So I got 3 over 54.
Right. And that's
Is that-
fine. That's you could simplify 3 over 54 by dividing the 3 by 3 and the 54.
Yeah, but that's so I did that step like that, and I got. Is that all right?
Yeah, that's totally fine because you're dealing
Okay.
with fractions.
Gotcha. Okay.
Right.
I just want to make sure.
Yeah,
Thank you.
that's totally fine. I just try to keep it smaller.
No, yeah,
small values.
I got a little bit confused right now but
Just
as long
just
as
so
I
you-
did,
yeah,
as
you
long
did
as
it
it's
right.
okay, I'm good. Okay, thank you.
3 over 54, you could divide this by 3, and you could divide this one by 3.
Yeah.
And let me just let Adriana in and write down her name real fast.
I did the same thing, Jacob.
Okay.
Yeah, I figured you guys did, but I did want you to see how you can make it easier. And welcome, Adriana, if you can hear me. But if I divide the 3 by 3 to reduce it, I get 1, and 54 divided by 3, I get 18. So you see, you get to 1 over 18.
Oh,
Yep.
okay.
Yeah.
Okay, Mr. Ray, let me ask. At this point, I think we can use the least common multiple for us to have the number that we divide.
Yes, that's what we're trying to get to at the very end. So well done, George, there. That
I
last
think-
number, if I just do that, is 4 times the 1, so that's 4 over 81. All right, so now we just need to, yellow?
Okay. If the least common multiple is 81, right?
Close. It's a little bit confusing there because you think 18 can go into 81, but 18 can't go into 81.
And even 2 cannot go to 81.
Say that again?
2 cannot go into 81.
No.
Yeah,
cannot
2
go.
can't go into 81. Yeah, but 9 can go to 81, but 18 can't. So that means you got to find a number that they all can go into. And so what number is that? Well,
162.
162. One way to think about this is that 9 times 2 is 18, and 9 can go to 81. Which more than likely is that double the 81, 18 should be able to go into that, if that makes sense.
Yes.
Right? That's one way you can find it. You know, if you're dealing with numbers that are kind of similar. And just again, if somebody missed it, because I know 9 times 9 is 81, then that means that 18, if it can't go to 81, it can go into the double of 81 because 18 is double of 9, if that makes sense. Does that make sense?
Yep.
Yes.
All right. So that means if I double 81, I know that not only can 9 go into it, but also 18, because 18 is twice the amount of 9. Right? So that means I could times 81 by 2. And what I do to the bottom, I do to the top. Then I just need to find out how many times can 18 go into that, into that result. And so that's going to be, I think, 18. Not 18, 9. Yeah, 18 times 9. And what I did to the bottom, I should have done a different color, make it stand out better. I'm just going to rewrite everything so that it's a lot of pink on there. So times that by 2. Everybody understands why I'm timesing that by 2, right? All right, so times it by 2, times
Because
by
you're trying to make the same denominator.
Right. And I was just using some divisibility rules there. All right, and then I just need to times 9 by 18, right? Because it's double that. And once I do that, I'm going to get all equal denominators of 162. Okay, so 5 times 18, was that 50 plus 40, so that's 90, I believe. Let me just check.
It's 90.
Yeah, that's correct. 90.
90.
So 9 and then 8. So remember, you add the numerators or subtract the numerators. So that means we know we're going to end up with 162 on the bottom. So 90 plus 9 is 99.
Minus 8.
And 99 subtract 8 would be
91.
91. And that's my final answer. 91 over 162. All right, so you see there is a combination of different things. You see the laws of exponents. You see understanding fractions, division, because you're doing cancellation. Laws come in multiple, right? All of those things are all intertwined into this one question. And that's why you want to constantly review. So unit 1 is the foundation. And just like in algebra, you're going to see the concepts from unit 1. And then these 2 sections we're doing from unit 3, these 2 lessons, you're going to see those basically being the foundation of algebra and geometry. So if you can master them, it really makes it easy. The harder part then would just be able to read the question, the word questions, and know what they're asking. But as long as you have the framework down, that can really help. And once we get to algebra, that's going to help even more with the word questions. Remember, this is kind of a side note with ratios. Remember, or proportions, whenever you see 2 comparisons of units, you can use a ratio or proportion. All right, let's go over how to do it. Question?
Yeah, Mr. Ray. So the way that Jacob and myself were doing it, like on the 54, we should have got the same answer though at the end. Is that correct?
You still get the same answer, yeah.
Okay.
Remember, you should reduce your work sometimes. You didn't have to, but I showed you guys that 3 over 54 is the same as 1 over 18.
Right.
So you still get the same answer. It's just when I work out stuff, I always try to reduce fractions and lower the size of the numbers. So the moment I see that, oh, I can cancel that 3, I'm going to take the opportunity and make that number smaller.
Okay.
Yeah, I prefer to work with smaller numbers, and I prefer to work with positives. So if I can manipulate them using math rules or math concepts, then I will do it. So you always see me lower a fraction to a smaller terms if I can. All right, let's go over how to do this on a calculator. Most of you guys, I think, have mastered that. And the more you practice, the better it is for you, especially to do well on the test. So you remember, you could type it just like you see it. So you could use the parentheses. Notice I don't use parentheses on the numbers. You don't really have to. So we have 5, open parentheses, 3 to the power of, I need more space there, -2. Make sure you come out and parentheses.
5.
So Clemente, are you watching for the calculator?
3.
Yes, I'm watching, Mr. Ray.
Okay, perfect. So did you see how to do that first start part?
Could you redo that again?
You want me to start over, or you want to
Yeah, can you start over again?
Okay, yeah. All right, so we're going to type in everything that we see just as we see it. And so you want to get familiarized with the location of the buttons too, and what each one does. So we have 5, open parentheses, we type the number 3, and then in order to get an exponent, remember the exponent button is this one here. That's highlighted red. That creates the exponent. It's a -2. Do not use the subtraction sign. Use the negative sign at the bottom.
Okay.
-2. Once you do that, you need to make the parentheses. A lot of students don't look at the screen. They just start typing. You want to practice looking at the screen. Just like when we drive, you don't want to look at the wheel only. You want to look up as well. You want to look all around. So So you look at the screen, oh look, it's blinking. If I don't click the arrow, notice that all my stuff is going to be up here,
Yes.
right? So that's going to create a problem. So the arrow is blinking to say click the right arrow. And when you do that, it brings it back down.
Okay.
All right, then you do close parentheses, hit the plus sign, and then you're going to hit the fraction button. Now remember the fraction button, we did that a few weeks back. The
Yes.
fraction button is n over d. So you can click the n over d. That allows you to put 3 over 2 as a fraction in there.
Okay.
So 3, use your arrows to navigate, 2. Use your arrow to come back out. All right, and then open the parentheses again, and you're typing in 3 to the power of negative 3. So 3, you hit the caret button thing,
Yes.
power of negative 3. Make sure you click the arrow to come back out.
Okay.
And close the parentheses, just as you see written
Yeah.
on the screen. Then you subtract. That is not a negative button, that's a subtraction sign. So you click the subtraction sign this time.
Okay.
And then 4. Then you see that the parentheses are open. Type the number 3. And then there's an exponent, so you got to hit the exponent button. It's a negative 4. Remember, negative has its own button, not subtraction sign. So negative 4. Look at the screen. The arrow's blinking to remind you don't start typing.
Hit the
Click
arrow.
the arrow button. Close the parentheses. You are done. Excuse me. And then now you just need to push enter, and you get the same answer, 91 over 162.
Thank you. Thank you, Mr.
All right, did you get it, Clemente?
Yes, I did. Yes, I
All
did.
right, that's great. You want to practice doing that? Practice using the calculator. Now, another way that you guys can do just the exponents is, you see here 3 to the power of negative 2. There's a button here, which is literally the exponent, the rule for negative powers. Right here. What's with this pen? Right here. Does everybody see that button?
Yes.
Yes.
Right. That button there is your, oops, I didn't mean to say that. That button there is your, yes, that's the negative power button. So you can click 3 and then click that button, and you see that it can reciprocate things for you. Now, the way that you reciprocate something like negative 2, if you want to use that button, right? Let's just say you wanted to reciprocate something. Let's say you had 3 squared, you just click that and it would invert it for you. So you don't have to use that button. It's just there so that you know how to invert. So it can invert anything. Let's say you want to know what is the inverse of the multiplicative inverse of 8, which is 1 over 8. You click that button and hit enter. It's going to reciprocate it for you. Good with fractions as well. Yes. Somebody call me?
I said that was nice.
Oh, okay. All right. You can do it with fractions. Remember, sometimes you have to reciprocate a fraction. So let's say you have to do that. Let's say you had the fraction 2/3. And remember, sometimes we reciprocate it. You can, I mean, you don't really have to use the button because you can do it yourself. But just to show you, if you reciprocate that, it's going to flip it for you. So that button just means to reciprocate. So if you ever just trying to do it really fast, like, what is this thing? If I reciprocate it, you know, just click the button and reciprocate. You can even do decimal numbers, and when you reciprocate it, it will give you the actual value in decimal form. So if you was trying to find the multiplicative inverse, you could just do that and it'll find the answer for you. So it can save you some time, especially if you understand what the problem's saying. Now, if you think that's too difficult, scratch it. You don't really need it, but it does help you in certain problems. All right, any other questions with that? All right, if not, in 3, 2, 1, we are going to move on to scientific notation. So I'm about to clear the screen, so hopefully you got a picture or copied it down. And I'm going to see something in the chat. Let me just check. Yes, Marisol, I got you. I think your audio was still connecting when I greeted you because you didn't answer, so I figured it was still connecting. But yes,
Oh, okay.
I got you, Marisol.
Good, thank you.
All right, and Adriana, you might have been connecting too, but I have you as well in case you were wondering, I got your name. All right, let's go ahead. Now I'm gonna share a PowerPoint in a moment. I'm gonna stop sharing this. And actually, let me go back to this first. So we're going on now to scientific notation. And in the book, whatever page this is, page, I don't know, do I have a page number? 56. Well, 56, you see a little paragraph there.
Student book, Mr. Ray?
Yeah, in the student book. We're not going to stay in the student book. I'm just introducing it in the student book. But on page 56, you see the intro for scientific notation. And so scientific notation is kind of self-evident. It's used in science, and notation literally just means how to write something. What's wrong with this pen? So scientific notation uses exponents and powers of 10 to write very small and very large numbers in a compact form that allows us to simplify calculations. Now, the way that we do it is that we use the decimal point, we use our understanding of that, and we maneuver it. So we're just going to go ahead and practice that for a bit. And I have a better presentation on that, so just bear with me. So much stuff open. All right, let me see, where is this thing too? Oops. And I should have that up and running in a few moments. Share screen, and there we go. Scientific notation. No, we don't.
What page was that, Mr. Ray? Sorry.
That was page 56, but we're not going to spend that much time on it. All right, here we go. Not sure if anybody saw that, but current slide. Okay. So just as you saw in that little paragraph, we're sometimes faced with very large numbers and then very small numbers. And by large and small, I don't mean by font. I mean by value. And I don't mean by the amount of digits there. We mean large, large, large values, such as this number here. Does anyone know what that number is? If you didn't see it, and I made a mistake and brought it up. But does anyone know what that number is?
Wow. Is it 24,000 billions?
Is it 24 trillion?
Okay, I heard 24 trillion and 24,000 billion. Both of those are correct. 24,000 billion is the right number, but we have a name for that, and that's what we call trillion. And at the time I created this, the U.S. national debt was $24 trillion. It's even higher now. Kind of a mind-boggling number. You couldn't count to it in your lifetime. There's just too many seconds in there to even do it, unless you was counting like super fast, but you still possibly couldn't do it. Anyway, it's a very, very large number. And the way that we're able to find that, if you've forgotten, is that you will look at each place value. All right, how about this very, very small number here? Well, actually, let's go over how to say it. There's this number here is in the ones place. And then we have tens, hundreds. Then we have thousands, 10,000s, 100,000s. Then we have the millions, 10 millions, 100 millions. You notice that pattern. If we go back, right? Ones, tens, hundreds. Ones, tens, hundreds, right? It keeps doing that. 1 million, 10 million, 100 million. 1 billion, 10 billion, 100 billion. And then technically, we have 1,000 billion. A billion is 1,000 million, but we have a name for it. We call it a billion. Once we get to 1,000 billion, we call it trillions. The next digit over would be 10 trillion. So that number is 24 trillion. Very, very, very large. Okay, and then for number 2, we have a very, very small number in terms of value, right? Because the decimal point is there, this is less than 1. Does anyone know how to say that number correctly? This one I could see more difficulty because most people don't say decimal numbers using the names. But if no one else is going to try it.
I don't even know how to start this one.
We start in the ones place. It's always on the left side of the decimal point. Once you pass the decimal point, you are in the tenths. place with a THS. And then it follows the same pattern as what we did up top here, right? It follows the same pattern. So we have tenths, hundredths, thousands, and then 10,000s, then 100,000s,
100,000.
right? Then instead of
Million.
1,000 thousands, we say a millions. And then instead of
Millions.
10 millions, 100 millions,
10 million, 10 millions.
and then billions. So that would be in the billions position. If you remember how to say decimal numbers, you say whatever number you see. So that's the number 93. And then you end it with the last digit's place value, which in this case, billions. So that's 93 billions. So that's a very, very, very tiny value. That's like microscopic and actually less than microscopic, like nano. It's really, really tiny. So because of that, we need to write these numbers in a different format, especially when calculating. And so if you can imagine, if you're a scientist that's studying space and the vast distances between universes and planets and stars, after calculating for a while, if you're saying, all right, 24 trillion times 80/5 billion times 2 quadrillion, you're like, man, this, I don't even know how many zeros I'm at right now, right? You're just gonna get bogged down. And then if you're a scientist studying nanotechnology, or you're a scientist studying biotechnology, meaning the body, like cells and viruses, then using regular numbers, you're gonna have these long amounts of zeros. So we need a way that we can condense it and make calculation easier. Now that's the beauty of the decimal system. It's based off a number, the powers of 10. And because of that, we can rewrite things really easy. So one thing I want you to notice, you might remember talking about this, that if you look at the amount of zeros in each of these numbers, they're directly correspondent with the power, what we learned about powers. Remember, 10 to the power of 0 is just 1. Notice that the number 10 is literally 10 to the power of 1. 100 is 10 to the power of 2. 10 times 10 is 100. That's 2 zeros. 10 to the power of 3 is 10 times 10 times 10. That's 1,000, which has 3 zeros. 10 to the power of 3. So notice the amount of zeros in a decimal number, base 10 number, is directly corresponding with the power that you have. Right, 10 to the power of 5, it has 5 zeros, and we call that 100,000. 10 to the power of 6, 1 million, has 6 zeros. 10 to the power of 7 has 7 zeros, we call that 10 million. So you see 7 zeros, the power is 7. It's the same in the microscopic and the tiny decimal realm. The amount of zeros directly corresponds with the power. But what we use is a negative power. Remember, we just learned that about negatives. What do negatives do? The negatives reciprocates. And so another way to write this, if you use your understanding of powers, 10 to the power of -1 is the same as 1 over 10 to the power of 1, which is a tenth, which is why we call it a tenth. You guys see the connection? It's the same here with, let me use yellow so that it's a bit brighter. 10 to the power of -2 is the same as 1 over 10 squared, which is the same as 1 over 100. We call that a hundredth, which is the same as, in a decimal form, hundredths. So that's the connection, and that now allows us to take these super large numbers and these super tiny numbers, and we can now rewrite them in an easier to manage, oops, I didn't mean to stop sharing, in an easier to manage format. And so what does that look like? Well, before I do that, I have this little screen up here. This is just to kind of connect to reality. So what you see here, you could take a screenshot of this or a picture of your phone. Remember when we was dealing with the metric system, and I said to you, there's other things out there, but we don't use it when we're dealing with the metric system. This is the basic metric system that we were doing when we were converting. But notice the titles here. When you have 10 to the power of -6, it's the same as a millionth, and we call that micro. So have you ever heard of a micrometer or a micron? We're talking about in the millionth. Or a microscope. A microscope is something that can zoom down to the millionth of a meter or a millionth of a unit. You might even hear nanotechnology. Might hear that in movies, right? Nano means 10 to the power of -9, and that's a billionth. So when we got that number, 93 billionths, it was like 93 nanos. So you might hear that in movies, nanotechnology. Then in the higher realm, you might hear this in computers. You might remember the Mega Man if you played that. You might have megahertz, right? Megabytes. Back in the day, megabytes was a big thing. Now that's like the size of an audio file. Now we're dealing with gigabytes. That's 1 billion bytes of information. And I have a hard drive, external hard drive, that's 1 terabyte. I could put so much stuff on there, and it still hasn't even got halfway. I have so much stuff on this terabyte drive. But that means 1 trillion bytes of information. And it's only a matter of time before you go even higher than terabytes. Right, so these are the prefixes to these big, large numbers. And so we call it scientific notation because clearly it's used in science and technology. All right, so now that you kind of got a basic gist of that, this is a great table to have. We're going to look at how to actually write numbers in scientific notation. So the way that we do it, it's simply a number between 1 and 10, which is literally, and using inequalities this way, it literally means that number can be equal to 1. It can be 1, 1.0, 1.1, 3.2, 3.5, etc., but strictly less than 10, meaning it cannot be a 2-digit whole number. So I can't have 10. I can't have 10.1. I can have 9.99999 because it's less than 10. I can have 9.8765321, right? But I can't have 10 because 10 is 2 digits. I can't have 50, etc. So first of all, we want to write it as a number between 1 and 10, where it can equal to 1. Then we're going to multiply it by a power of 10. As you saw, powers of 10 are like 10, 100, 1,000, etc. But written as in exponent form. An exponent form just means the amount of zeros following the 1. So here are 2 examples of what a number looks like in scientific notation. Notice this very large number. 2.5 is between 1 and 10, this first part. And then the base 10, or the power 10, is 10 to the power of 15, which means that you have 1 followed by 15 zeros. Now, instead of having to write that out over and over, we can condense the 1 followed by 15 zeros to 10 to the power of 15. Does that make sense? Did I hear a no?
No.
No, it doesn't make sense?
It makes sense, but
okay. It's going to make more sense as we go on. So I just want to make sure no one is lost yet. All right, then here's an example of a very small number. Once again, notice the negatives. Remember, I just showed you about the negative button on your calculator. The negatives indicate a very small number, tiny numbers. That's why when we were doing those, like number 8 and number 6, we were reciprocating. We was reciprocating from a regular number to a fraction, and a fraction is part of a whole, a smaller number. So negative powers indicate small values. Hopefully that makes sense.
Yeah.
All right, perfect. So what we're going to look at now is just to see if you guys understood those rules. Because one of the biggest issues we have is that people don't write their answers correctly because they don't fully understand the rule. So which of these numbers is not written in scientific notation form? 3 of them are correct, 1 of them is not. So which one is incorrect and why?
I think C.
Yeah, here's C.
Yeah.
Do you want to give a reason why, George?
To my own opinion, because I don't find any decimal point there. Even when we convert, yeah, there's no.
How about D? D doesn't have a decimal point. I'm not saying you're wrong, just saying if.
So, Mr. Ray.
Yeah.
So I think George had it right. You know, C, but can we do instead of 40? Could it be 4 times?
But Why not 40? What's the main reason? What
Because 40 is greater than the 10, isn't
there
it?
we go. That's what I was basically looking for. So well done, George. Well done, Salvador, for for going deeper into that. It is that. That's the reason why. And so 40 is larger than 10. It's not a number between 1 and 10. So if you ever get asked that, that could be a question on GD. Which one of these numbers is not in scientific notation form? That could be an easy point for you to get. Right? 40 is not a number between 1 and 10. So that is not the correct way to write scientific notation.
Okay.
Now, this is a general rule. So if you're in Japan, if you're in Argentina, if you're in Nigeria, if you're in Holland, doesn't matter where. This is the rule across the world in how to write numbers, scientific notation numbers. That number has to be in between 1 and 10. That's a commonality so that there's no inconsistency since we are a global market.
So Mr. Ray, so that number could have been like 9.9, like you said, huh?
Yeah, it could be 9.999 as long as the value is less than 10.
Okay.
All right, let's try another one. Once again, which one of these numbers is not in scientific notation form?
The A.
Okay, I hear A, why A?
Because the time, it has to be the greater than 10, right? Times greater than 10, so it had to be.
I think you're getting the right answer, but you're not saying it correctly. But I think you're on the right track. So are you trying to say the number that is being multiplied by?
Right.
The number that is being multiplied has to be a base 10.
Right.
You're correct. Yeah. So it's this one, and because that number is 1 and not a base 10.
So a base 10 number could be 20, 30, 40, 50, 60?
No. Say that again.
A base number could be, a base 10 number format could be like a 20, 30, 40, 50?
No. Base 10 means 10. Remember,
just 10.
I
I thought you meant in the tense numbers. Okay.
Oh, no. Base 10 means that your 10 is the base. You remember in exponents, the base is the number that's being multiplied by itself.
Okay.
So,
I'm thinking of the tenth of a number, like 20s, 30s, 40s.
Yeah, so 10's in the terms of base 10.
Okay, got you.
10, 100, 1,000, but instead of written in the long form, written in exponent form. So instead of 10, 100, 1,000, 10, 10 squared, 10 cubed, etc. Instead of 0.1 or a tenth, 10 to the power negative 1. Instead of 10 to the power negative 2, 1 over 100, 10 to the power negative 2. All right, how about this one here? This is the last one we look at to see, can we identify?
Yes, C.
C or D? I hear C. Anyone else agrees?
Yes, C.
Yeah.
A, Y, C.
The first amount is greater than 10.
First amount's greater than 10. It has to be between 1 and 10, right? Because it's just over 10, 10.32. It's wrong. The whole number part is a 2-digit number. So 10.32 is not a number between 1 and 10. Right? Does that make sense?
Yes, I'm getting it now.
This is important because you're going to be asked to write numbers into scientific notation. And they're going to give you a choice selection where some of the numbers are not between 1 and 10 in the first part. And it's going to be very tempting. Sometimes they put it as part A and B. And so you got to be really careful. The number part, the first number has to be between 1 and 10. The thing that you're multiplying by has to be in base 10 format. All right, so this is kind of just a recap of the place value system and what's really happening. Notice that I have the base 10s on top because that's what the base 10s mean. 10 to the power of 0 is 1, right? We've rehashed that. And just in case you're not sure where I am, 10 to the power of 0 is just 1, or the units. I should have put ones there, but 10 to the power of 0 is 1. Yes, George?
So that again, okay, the number must be from 1 to 10. Then the other number must be from where to which positive number?
The other number is to be in base 10 format. So base 10 format is this. But I'm showing the equivalence now between base 10 and the actual place value. So 10 to the power of 0, it's 1, right? Anything to the power of 0 is 1. 10 to the power of 1 is just 10. 10 to the power of 2 or 10 squared is 100. 10 to the power of 3 is 1,000, etc. And so basically what you're seeing is just rewriting the number so that it's easier to manage. Now, something we want to notice is that when we multiply each of these by 10, it's like adding, right? Remember with the exponents, when I multiply 10 to the power of negative 5 by 10, that's like adding 1. It's 10 to the power of 1 times 10 to the power of negative 5, and I add the exponents. It becomes 10 to the power of negative 4. If I multiply it by another 10, it's like having 10 to the power of negative 3, right? If you're not sure what I'm talking about, let me write it out here on the side. If I had 10 to the power of negative 5, and I times it by 10, remember 10 by itself is really 1, that becomes 10 to the power of negative 4, because I add the exponents. And so each time I multiply by 10, I am adding an exponent, right? Does that make sense? 10 to the power of 0 times 10 is 10 to the power of 1. And I'm adding the exponents as I multiply. So that means each time I multiply by 10, my exponent increases.
And it doesn't matter if you start at the decimal point or at the thousand.
Doesn't matter. Every time you multiply by 10, that exponent increases. Same way, if I divide by 10, my exponent decreases. So each time I divide by 10, I am decreasing the exponent, right? So that's what's happening in the decimal number system. That's why we're able to convert the metric system, because it's all about multiplying by 10, dividing by 10. Remember when we multiply decimals, we would move the decimal points and count the place values? It's because everything's based off of the number 10, multiples of 10 and factors of 10. So it'll make more sense as we move on, just in case it did not. So let me just skip through this. Actually, this is easier to comprehend. So 10 to the power of 0, if I multiply it by 10, I have 1 10. If I multiply it again, I have 2 10s. If I multiply again, I have 3 10s, or 10 to the power of 3. So each one represents a multiplication of 10. So I'm going to skip through all of this. Okay, here we go. So the reason why we're learning all this is because when I want to rewrite 10 to the power of 7, the real reason why is I'm counting the place value. If I count the place values like multiplying by 10, 10 squared, 10 to the power of 3, 10 to the power of 4, 10 to the power of 5, 10 to the power of 6, 10 to the power of 7. So 10 million, using that understanding, is 10 to the power of 7. When I go the opposite direction, I am dividing by 10. And remember, we just rehearsed, dividing by 10 is the same as negative powers. So when I move the decimal point on the bottom, that's like dividing by 10, or 10 to the power of negative 1. If I move it again, if you look at the bottom screen, 10 to the power of negative 2, 10 to the power of negative 3, 10 to the power of negative 4, 10 to the power of negative 5, 10 to the power of negative 6, 10 to the power of negative 7. So I can rewrite that as 10 to the power of negative 7 because I divided by 10 7 times. Does that make sense?
Yes.
All right, so let's put this all together then. Here's an example. The approximate distance between the Earth and the Sun is 93 million miles. Write this in scientific notation form. Well, the first thing is I want the number to be between 1 and 10. So I want to know where to put my decimal point. I want to put my decimal point between the 9 and the 3. That means it's less than 1, between 1 and 10. If I put the decimal point in the front of the 9, that number is less than 10. If I put the decimal point behind the 3, the number is greater than 10. So I want the decimal point in between 9 and 3. Does that make sense?
Mm-hmm.
Then I simply count how many times I would have to multiply by 10 to make that true. And I start at the end of the decimal point. So that's 1, or 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, 10 to the power of 5, 10 to the power of 6, 10 to the power of 7. And that's my answer. 9 and 3/10 times 10 to the power of 7.
Okay.
Does that make sense?
Wow.
Mm-hmm.
All right, let's try number 1 in the book. So if you turn now back to page 56 in the student book, and I'm just going to switch screens real fast. And I'm coming back to that. So if you wanted to get that, don't worry. I will be back to that again. And my computer's dying. Let me plug this in before I disappear. So number 1 in the student book, if I can scroll down, says the distance between the sun and Mercury is about 58 million kilometers. What is this distance written in scientific notation? Is it A, B, C, or D?
It's B.
What page are we in?
It's B.
Page 56. Okay, I heard B. I
E.
heard
B.
two Bs. Okay, and that is correct. It is B.
All right.
Right, and you can just count that. You could count by threes. That's easier. You could just say 3, 6, and then 7, because that's where you want the decimal point, between the 5 and the 8. Notice here, they have the violations. These are not in scientific notation form, although one of them is the same number, right? If you used to multiply out C, you notice that C and B are equal, but C is not in scientific notation form. And
Yes,
so
I noticed those numbers were greater than 10.
yeah, yeah.
And
So
then I just added the decimal.
right, that's all you want to do.
Counted to 0.
When you see it,
Mr. Ray, I have a question.
yeah.
Yeah, when you're writing in scientific notation, you always have to have a decimal.
No, not always, because let's say it was 50 million, right? You don't really need the decimal there, because when you move the decimal point, you could write it as 5.0, but the answer could be as 5. So it could be 5 times 10 to the power 7 or 5 times 10 to the power 7. It's still the same. The rules for decimals are the same. It doesn't matter how many zeros follow, it's still the same number. It's just, you just want to make sure you choose the right selection in your choice. But yeah, it doesn't matter when it's a 0 following. Sometimes it does, because they might tell you to the nearest 1 decimal place or the nearest 3 decimal places. So let's say you had an answer such as 58,325,480, and then they say write it in scientific notation form, but round your decimal to the nearest 2 decimal places. Sometimes that can come up. So you would count, right? There's 3, 6, 7. So 5.8. And if they say the nearest 2 decimal places, means you include the 3, you cut off everything else times 10 to the power 7. So that can actually happen, where they ask you to round your last answer. And since I brought that up, the reason why they might ask you to round is because technically you always write every non-digit number. So you can see it will kind of defeat the purpose of using scientific notation if I still have all these digits following. So sometimes they might ask you to round your final answer to 2 decimal places or 1 decimal place. If they ask for 1 decimal place, you're going to end up with 5.8 times 10 to the power 7. Does that make sense?
Yeah.
Yes, Mr. Ray.
All right. So that's possible. They could
Yes.
ask you to round your scientific notation answer. And as long as you remember to round, it's the same rules for rounding. All right, so that's how you do that. Then we just want to look at how to do the negatives. So I'm going to reshare. Actually, let's just try number 2 real fast. Just make sure everybody's got this. Number 2, there are 25 million. Should have asked you guys to see if you could say those number correctly. But anyway, there are 25,400,000 nanometers in an inch. What is this number written in scientific notation?
A.
There, here, A,
I got B, sir.
B,
E.
E.
or B. All right, notice this
I
one
got B.
here. All the beginning numbers are all written correctly. They're all between 1 and 10, because that's exactly where you want the decimal point, between the 2 and the 5.
My bad.
Right? But then you're counting how many times. You can count 1 at a time, or just group them 3,
3, and 7.
So that means 10 to the power of 7.
I think that's
Right.
what my problem is.
Yes.
Pretty straightforward, right?
Yeah. I get that.
Now, before we get to that, we need to practice the negative ones. I'm just trying to see what other problems they have on here. We might have to go to the student book. All right, so sometimes they ask you to do negatives. And let's skip over to that. And I'm just going to skip through this really quick once I get it situated. All right, so we're going to skip through all that. Okay, there we go. Okay, does anyone know what that is? That's the 3D image of the so-called coronavirus. So we see there what it would look like. There's like little crowns on the virus. But the size of the virus is at most, they could be different sizes, but the largest approximate at the time I got this, they might have found out more information about it. I haven't checked. But since the last time I saw it, the largest approximate width of a coronavirus strain was 14 microns or 14 micrometers, or another way to say that, 14 millionths of a meter. So you might hear them say 14 microns, which is the same as 14 micrometers, which is the same as 14 millionths of a meter. So it's super tiny. You can't see it with the naked eye. You would need a microscope to bring it into your sight or anything more powerful than that. All right, so we're going to write this number into scientific notation, because if you're trying to calculate how many viruses can fit in a petri dish, that would be a lot of calculation there with those zeros. So what we're going to do is remember the rules for you're dividing basically, or you're going in the opposite direction. So remember, we want the decimal point to be in between the 1 and the 4. If it's before the 4, it's 0.14 or 1400ths, that's less than 1. If it's after the 4, that's 14, which is larger than 10. So you want the decimal point between the 1 and the 4, and then you're counting to see how many powers of 10 that is. Remember, with the negative powers, you're dealing with decimals. So remember, you're counting, I could skip through that, you're counting -1, -2. Please keep that in mind, -3. So you're counting the negative values it takes to get to that decimal point. I don't know why I have all this here. All right, so let's count that. That's 1, 2, or 10 to the power of -2, 10 to the power of -3, 10 to the power of -4, 10 to the power of -5, 10 to the power of -6. Do I stop there?
Yes.
Yes, because that's where the decimal point needs to be. So that's my final answer. 10 to the power of -6. So 1.4 times 10 to the power of -6 is how I can calculate that.
So let us go back again. Let me understand. I don't know.
All right, so you're dealing with, because you're dealing with a small value, assuming you see those zeros, you want to think that you're dealing with the negatives. You're dividing by 10, right? You're going into the decimal round. So because you're dividing by 10, remember to divide by 10 or divide in the exponents. 1 over 10 is the same as 10 to the power of -1. We just did that with indices. So that means when I'm dealing with these, and remember 1/10 is 0.1. So if I got a really small number like 1,000, that's 1 over 1,000, which is the same as 10 to the power of -3. So whenever I see decimal numbers or fractions, I'm dealing with, proper fractions that is, a negative power. So automatically, I should be counting with the negative in mind because I'm dealing with small numbers. So I count the place values. That's 10 to the power of -1, 10 to the power of -2, 10 to the power of -3, 10 to the power of -4, 10 to the power of -5, 10 to the power of -6. So that becomes 1.4 times 10 to the power of -6. All right, does that make sense?
Yes.
Right.
It makes sense, but I don't know.
Let's try some more. Hopefully you can count these. You might get closer to your screen. I know the negatives normally give some trouble. So remember, you look, excuse me, you see decimal numbers. Hopefully you remember from all the stuff we did in Unit 1 that a decimal number is a small number. And small numbers, remember we learned the conversion between decimals and fractions. And now we've learned the conversion between a fraction and an exponent, right? In case you're missing one step, let me bring this over just so that you hopefully see the connection between everything. Oops. Man. What in? Okay, there we go. That's all I wanted to do, computer. Remember, 1,000 is the same as 10 to the power of 3, and 1 over 10 to the power of 3 is the same as 10 to the power of -3. These are all equal and or equivalent. And because they are, we can use all of our understanding of these to make our life easier in mathematics. Now, some people say, it's making my life harder. Well, in the long run, it actually makes life easier. So if you get into, if any of you are interested in trying to become like a software engineer or work for Tesla or something, you're dealing with very microscopic things, right? You take apart your computer, and you look at that motherboard, you're gonna see really tiny chips and stuff, right? The people who are doing that are dealing with these numbers. So soon, when you see those decimal numbers, you think negative powers. Remember the rule? You want the number to be between 1 and 10. So where do I want the decimal number for this first one? Before the 6 or after the 6?
4.
Okay, you're just saying the answer. All right, I want it after the 6, and so I count how many times I move that. 10 to the power of -1, 10 to the power of -2, 10 to the power of -3, 10 to the power of -4. So that's 6 times 10 to the power of -4. Where would I want the decimal point to be for the second number? Before the 7, between the 7 and the 2, or after the 2?
Between the 7 and 2.
Between the 7 and 2. Now I count how many times I move the decimal point. 1, 2, 3, 4, 5, 6, 7. So how do I write that?
7.2 to the power of 10 -7, we count it?
-7. Now make sure you have the multiplication sign in between those two. So 7.2 times 10 to the power of -7. If you used to type that in your calculator, it's going to give you the same answer you see on the screen. All right, let's try this next one. Where should the decimal point be for that third one?
In between the 2 and the 0.
Well, if we do that, it would be 50.2.
Oh, okay.
After the 2. So
After the 5.
Okay, after the 5, right? After the 5 would give us 5.02.
Okay.
Right, so we want the decimal point. Let me draw it in there so everybody can see it. Decimal point right there, 5.02. That way it's less than 10.
Oh, okay, okay.
Right, so we count how many times we move the decimal point. And lost control there. All right, 1, or 10 to the power of -1, 10 to the power of -2, 10 to the power of -3, 10 to the power of -4, 10 to the power of -5. So how do we write that final answer?
5.02 times 10 to the -5.
And there we go. That's the correct answer. 5.02 times 10 to the power of -5. All right. The next one, where would the decimal point need to go?
After the 3.
After the 3. So we count 10 to the power of -1. I'm just going to say -1. So -1, -2, -3, -4, -5, -6, -7, -8. So how do we write that number?
Which is
3.29 times 10 to the -8.
All right, that's correct, both of you.
Negative power to the 8.
You can say 10 to the -8, or
Okay.
because it's two ways you can say it: 10 to the power of -8, or 10 to the -8 power. Now, because we're humans after a while, people don't like saying power, so you hear people just say 10 to the negative 8.
Okay.
You know, it's acceptable. People know what you're talking about. But technically, you're supposed to say power. But if you say 10 to the negative 8, people know what you're saying. All right, the last one. Where should the decimal point go there?
After the 1.
Right after the 1. And we count how many times. How many times are we moving it?
1, 2, 3.
Okay, 1, 2, 3.
3.
So that becomes 1. I meant to ask you first, but anyways, up there. 1.008 times 10 to the power negative 3.
And
All
a
right.
screenshot.
Does that help any?
Yes.
Yeah.
All right, great. Okay, we're going to take a break from doing it by hand, and I do want to show you how you can do it on your calculator. All right, so hopefully you have your calculators ready. You don't have to do this. Most people find scientific notation, once they learn it, pretty straightforward, at least straightforward questions. Because they are going to ask you questions here and there where you have to do computations. And that's where the calculator can really come in handy. So let's go over how we can use the calculator first just to change the numbers. Then we're going to learn how to actually use them correctly in terms of computation. Excuse me. All right, so first thing you want to do, it just depends what you want to do. If you want to change it from a regular number to scientific notation, you want to click mode. All right, once you click mode, if you look at the second row, you see norm. Basically, norm means normal number, a regular number, ordinary number. That's basically what norm means. So we normally have it set in norm. Do you see what setting I should highlight now? SCI, that's correct.
Yes, science.
SCI stands for scientific notation. So if you use your arrow and let it blink
Okay,
over there.
we'll move the arrow.
Yeah, move the arrow so that it's blinking over SCI, click enter. And what you'll notice is that actually right on the calculator, your mode has changed and you can literally see it. You see there, SCI?
Mm-hmm.
Once you click enter, your calculator is now in scientific notation mode. So remember, how do you get out of here to get back to the calculator screen?
This is second function mode.
Second mode, which is the same as the quit function, and now you're back. Now, any number that you type, if I put 8 and then hit enter, that number is going to come up in scientific notation form. If I click 98, it's going to come up 9.8 times 10 to the power of 1. If I put in 102, it's going to come up 1.02 times 10 to the power of 2. And so any number that I put in there will come up into scientific notation form. So if I have a number such as number 1, which is 58 million, I can type in 58 million. That's 6 zeros, so 3, 4, 5, 6, and I can get the answer right away. Same with that second number, it was 25,400,000. Type that in, 25,400,000, and hit enter, and got my answer. All right, now you see why I say it's good to have this calculator if you can learn it.
Oh, it's doing it, yeah.
Yeah, it could really save you a lot of time.
25 million is 2.5 times 10 to the 7th power.
Yep.
Okay.
And it can improve your accuracy.
Oh, yeah.
Means you can get more questions right and in a faster time, because the majority of the tasks you can use the calculator. So if you know how to use it, it can really, really help you out. All right, so let's try some decimal numbers. They don't have any decimal ones in there. So let's put some decimal ones in there. I'm just picking up other conversations, so I'm just going to mute everyone for now. Let's say you have 0.0008, right? You want to see what is that number in scientific notation. That's going to be 8 times 1, 2, 3, 4. 8 times 10 to the power of negative 4, and that's what you get. 8 times 10 to the power of negative 4. All right, so any number can be rewritten into scientific notation All right, just hitting the enter button. Any questions about the calculator?
No, sir.
No, sir. That's so
All right,
far.
are you glad that you learned it? Do you think it will help you?
Oh, yeah. Yes.
Yes.
Okay, now
Big
let's
time.
get it back into the regular format. How do we do that?
Press mode.
Okay, we click mode and then what?
Go to norm. Click
Okay,
down to
we
norm.
navigate to norm and then
Enter.
enter. Watch that. You see the SCI disappeared. So it's back into
Disappeared.
normal mode,
Then I clear it.
right? But how you get back out?
Clear.
Not clear. Oh yeah,
Oh, no?
clear works. You know, I've never tried using clear.
I used it and it worked.
Yeah, thanks for telling me. I never used clear before. So I just learned something new. Thank you, Gennaro. So you can push clear instead of doing second quit. Most calculators you have to do second quit. So TI-30 obviously stepped it up. It's like, let's just make it easier for everybody. Just click the clear button.
So after we do that, what are we supposed to see on the screen now?
So if you type any number now, you're going to get the same numbers. If I type 9, I get 9. If I type 0.023, I'm going to get
Okay.
0.023 if I push enter. Because now
Okay.
it's back in normal mode.
Okay. Thank
All
you.
right. You're welcome. Now, we're not going to do any calculations today. We'll do that on Thursday. Sometimes you're asked to go the opposite direction. Sometimes they give you a number in scientific notation form. And guess what you have to do with it?
So a number. Say that question again, sorry.
Sometimes they give you a number in scientific notation form, like this one.
Okay.
And they ask you to rewrite it in terms of a regular or ordinary or normal number, right? Any of those phrases can be used or anything synonymous to that. So here
So-
we have, go ahead.
Oh no, go ahead.
All right, so first we're going to do it by hand and then the calculator. And then Thursday, we're going to practice doing the calculations, stuff that's like in the homework book and whatnot. All right, so the mass of planet Earth is about 5.972 times 10 to the power of 24 kilograms. That is mind-bogglingly big, large value. I mean, just kind of unfathomable. Anyway, what is this number written as an ordinary number? Well, the good thing is, if you have a calculator part of the test, you could do it right away. But you never know what part would be calculator and what parts will be non-calculator until you get on the test. So to take this number from scientific notation form and then rewrite it back into ordinary form means you do the opposite, right? So if I go 3 steps forward, how do I get back to where I was? 3 steps backwards. So if I traveled 24 place values to write the number this way, then in order to write it back the opposite way, I need to head back 24 place values in the opposite direction. And so you can always tell which direction to go by the exponent. Because the exponent is positive, will this be a large number or a small number?
A large number.
Large number. So which direction would the decimal point have to go?
Positive. Right. Positive.
Right. That's the only way to get a bigger number. If I go to the left, I'm getting small numbers, right? Decimal numbers, negative power. Large numbers, large power. And as long as you remember that, if it's by hand, it shouldn't be any problem. Some people get mixed up. What direction? Right? Just remember your number systems and you should be fine. Okay, so remember the 24 means that there are place values, 24 place values after the decimal point. So you already have 3 of the place values used up. So that just means you need to count some more zeros to come after that. Because notice you can't count unless you have some zeros or place values there. So since 3 have already been used up, how many zeros would I have to put behind that 2 in order to count?
21.
21. So I'm going to need to put 21 zeros so that I can count. Now I could go by 3s and make it easier. So 3, and then I need to make sure I get 21 zeros after. So 3, 6, 9, 12, 15, 18, 21, 24. So 24 place values, but 21 zeros need to be after that too. And then I just take the decimal point off and put the commas in the right spots, and that's my answer.
That's a big number, Mr. Ray.
Very big number. Does anyone know how to say that number?
No.
I'm pretty sure if you research it, you could, but just in case you was wondering, that's a septillion.
Wow.
And if you're wondering how those numbers work, there's basically prefixes that, depending on what language you're
Sorry,
familiar with, it's just the prefixes for.
Mr. Let me ask a question.
Sure.
For the place value, we have 5.972, and for 24 in the power of 10, I think that we'll have to subtract 3 for this 0, 0, 0, it will be 21 instead of 24.
Say that one more time. You say you have to subtract 3?
I'm talking of the zero figures. I think that it should also have been 21 rather than 24 zeros. 1, 2,
All right,
3.
no, it's 21 zeros.
Okay.
Yeah, that's what I said in the beginning. There's 21 zeros,
Okay.
but 24 place values, because 9, 7, and 2 are place values. So you got to count those as well.
Okay.
So
Okay.
if you look back here, you see right here the 21, so 24. So from the decimal point to the end, there's 24 place values. But the amount of zeros that I need to write to save us time is 3 place values have been used up. So there's 21 zeros, which you correctly stated. And that's how I know how many zeros to write, if I have to write it by hand. All right, so that's how you do that. Let's just try a few real fast. 756. All right, so 6 times 10 to the power of 0, what would that be as a regular number? 6 followed by
6 by 6.
9 numbers? 9 tens? 9 zeros, I mean.
Okay, I heard 9 zeros.
10.
I heard 10 zeros. So one of those 2 are correct. It's 10 zeros. All right. 8.2 times 10 to the power of 7.
Will be 6 0.
6 zeros, right? Because 2 is a place value. Remember, it's really the place values you're looking at. So since a place value has already been used up, that means there's 6 place values left, or 6 zeros that would go there. So 6 zeros need to come after that. 2, remove the decimal point, 82 million.
So
how about the next
one,
number?
10 zeros.
7.
It's
8
8 zeros.
8. Yeah, it'll be 8 zeros.
Oh, I'm sorry, yes.
Right? 11 place values. That's what the exponent means. 3 of those place values are already there. So you just remember when you count that, then just put 8 zeros behind that 4.
So on the next one, it's 4 zeros.
Right, you got the picture. Next one is the 4 zeros follow that 9.
I'm getting it now. Let me
Right. Remove the decimal point.
How about on the last one, Mr. Ray?
The last one's a tricky one.
Those zeros.
The last one's
those
tricky.
zeros?
Look at it carefully.
No
So
zeros.
it's no zeros, but where does the decimal point go?
It has to come from the left, from the right. I think from right going to left.
We just move the decimal point 3
Yes,
spaces.
3 times.
Yeah,
3
just
times.
move it 3 times, right?
Yes.
If you move it 3
Yes.
times, it'll end up between the 4 and the 6. There are actually more values than the amount of times you can move it. All right, so all of those were just kind of shortcuts to kind of help. The long way would be to write it out, but the thing is you want to maximize time. So what happens is a lot of students are writing all these zeros, and then you got to count and erase the zeros. But if you just observe, you know, I'm counting place values, and if I see how many place values you use, I know exactly how many to put. All right, and let's do the negatives. How much time we got? All right, let's knock this out in 3 minutes. The negatives are very similar. You're just going the opposite direction though. But because you're going the opposite direction, it's pretty much the same every single time, the same concept. Because there's only one decimal point and therefore only one unit can be after the decimal point, then it's pretty.
3.
So I heard 3, yes, there's going to be 3 zeros that are going to be in front, but you want to make sure you put the decimal point in the right spot. The decimal point is going to be following the 3 zeros and then another 0. And that's what normally throws people off. So because that other 0 represents the ones place and we're supposed to write the ones place, another way that you can look at this, and you just need to choose which method, you can look at whatever number's there, that's how many zeros, and just make sure you put a decimal point. That's one way you could do it. And the reason why is because yes, you move it 4 times and therefore 3 zeros, but when you write decimal numbers, you have to write that 0 in. Does that make sense?
Yes.
Because you have to write that 0, you could look at it just by saying, I have 4 in the power, so 4 zeros. All right, so here, I'll just do it real fast. It's 10 to the power negative 5, so 5 zeros. Make sure you put a decimal point. For the second one, it's negative 6, so 6 zeros altogether. Put the decimal point after the first 0. For the next one, how many zeros? And we're going to put
8.
8 zeros and a
Mr.
Decimal
Ray,
point.
decimal
Mr.
point.
Ray,
Yes.
yeah, let us look the second one. We have 4.83. I think we consider it like the previous one that we have 2 decimal places.
No, no, no. This one, we're going the opposite direction because it's a negative power. All right, so opposite way because we're dealing with the negatives now. We're not with the positive values. So we're going smaller. So I didn't do that this time because of time. But remember, because it's a negative power, right? Because it's a negative power, that means we're dealing with small numbers. Because we're dealing with small numbers, everything's in the front. We're not worried about the back anymore. So because everything is in the front, we're going the opposite direction. When you're dealing with the front, it's easy just to say whatever the power is, that many zeros, put a decimal point. So 10 to the negative 8 would have how many zeros in the front of that 1?
8.
8 zeros and a decimal point after the first 0.
Yes.
Right? How about the next one?
7 zeros.
And a decimal point after the first 0. And this last one here?
2 zeros and a decimal point.
2 zeros and a decimal point. Right? Take a screenshot of that. Unfortunately, it's none in the textbook. So you want a picture of that. Take a picture with your phone. Take a picture of the screen, whatever. On Thursday, we'll just review how to do this in a calculator. It's very simple. Just type what you see. If you want me to do it, I could do it real quick, but you're officially dismissed. I know some of you will have to run and it's late.
Thank you, Mr. Ray.
I'll do it real fast and then we'll just be done. But just make sure you get a screenshot of this. We'll pick up here on Thursday.
Excellent.
And so just make sure you have your calculators. Review it, please.
Mr. Ray.
Yes.
Mr. Ray, I think what gets some of us confused is that on the when you go to the positive side, you include the numbers that are there already after the decimal. When you go into a negative side, you don't include the numbers. You just count the zeros.
Well, you technically can. That's why I say you want to be careful with this one. You can have 2 ways. It's whichever. If you want to just include what's there, you would ignore that first 0. But then some students forget to write the 0 back in.
Okay.
And so that throws people off. So like for this one here, come on, pen. What is wrong with this computer?
All right.
It would be because I'm trying to hurry up. All right, so for this one here, right, you could use that first thing. You could say how many zeros would be in front. Well, there's a 7 already, so 4 zeros. You could do that, but you have to remember that because you're dealing with a decimal point, you need to put the decimal point there and the 0, because that's how we write our number. And that confuses people. So because of that, I say, well, if you want to look at it different so you don't get confused, you could just say, when you're dealing with the negatives, just have 5 zeros and put your decimal point there.
Okay.
Right.
So put the zeros and put the decimal point. Okay. Got it.
Yeah, it's 2 ways you could look at it. The way that we were doing all this time, but sometimes we say, some people, just to get around it, they don't tell their students to write the last 0. But some students get confused and it's like, but it's another 0. So wait, no, I need to put the decimal point. Oh, I'm confused. So, but it's really just practice. The more you practice it, easier it gets.
Yeah.
Okay.
All right.
Thank you, Mr. Ray.
Practice the same things over and over. So hopefully everybody took a picture of it. Like I said, Thursday we'll pick up here and go over how to do it on a calculator, and then we're going to learn how to do calculations, addition, multiplication, etc.
All right. Thank you, Mr. Ray.
All right, you're welcome. Enjoy your evenings.
See you
All right.
on
Thank you.
Thank you, Mr. Ray. Good night.
All right, night.
Thank you, Mr. Ray.
You're welcome. Enjoy your evenings.
Good night.
Talk to you Thursday.
Yeah, see you guys Thursday. Be
Thank you,
safe.
Mr. Ray.
You're welcome.
Mr. Ray, I have a
Yes.
question, because since I'm not here on Thursday, really, is it any chance, is there any way that you can record your session?
I actually do record them. I've been trying to get them on YouTube, but it's just, it takes some time. But I've been supposed to record each of them. But yeah, they are recorded. I could try to send it to you, this specific recording
Okay,
on Thursday, but you have to remind me.
I will.
Yeah, so you remind me, it's recorded, and I can send it to your email. I
Okay.
can't put it in Remind, it's too large of a file.
Right.
Hopefully I could email it. It might be a large file too, but I could possibly get into Microsoft Teams or something. I'll figure it out. But I'm supposed to be putting them on YouTube, but
Okay.
it just takes time to do that, so I haven't been able to start them. But yeah, if you remind me, I'll try to get that to you.
I will.
Okay, on
All right.
Thursday.
Yeah, Thursday. See you guys Thursday.
Okay, sir. Have a good night, guys.
All right, have a great evening. All right,
Bye-bye.
Ray, do you have a question? George, have a good one.
Bye, sir.
All right, bye, Latavia. All right, so I'm ending it now.